Hello, everyone. Looks like we're at the top of the hour, so let's get started. Welcome to the 2025 CEETRON Product Update webinar. I'm Cherise Dalton, Regional Marketing Manager at TechSoft 3D, and I'm thrilled to have you all with us here today. We've had an exciting year of progress with CEETRON, and we can't wait to share the latest developments and innovations that are shaping the future of our CAE solution. To ensure a smooth experience, all attendees are in listen-only mode, but we do encourage you to participate. So if you have any questions during the presentation, simply click the questions icon at the bottom of your screen, and we'll address as many as possible during the Q&A session at the end. This webinar is being recorded, and once the recording is available, a copy will be sent to your registered email address after the session. Your insights matter to us, so we ask that you please take a moment after the webinar to complete a quick feedback survey. Today, I am joined by my colleagues and industry veterans, Jonathan Giroir, Senior Marketing Director, Developer Toolkits, and Andres Rodriguez-Villa, Director of Engineering, CAE. Please join me in welcoming them. So Jonathan, take it away.
Absolutely. Well, thank you so much, Cherise, and welcome everyone. This is an annual thing that we do, talking about what we've delivered in the last year, specifically focusing on our CAE tools, and then what we are planning to do this year as well with an exciting demo. So that's where we'll be at, looking at the highlights of major releases. We'll look at the roadmap, and then something I'm particularly excited to preview is the CAE Streamer. What is that? Well, you're going to have to wait and see what Andreas has cooked up and his team, but that's pretty exciting technology, and you get a good preview of it now, something coming later this year, pretty soon, actually. So I kind of looking at all of our attendees, some familiar faces, so welcome everybody, and then some new ones as well. So just to give you a quick overview before we get into the technical details, who is TechSoft 3D? Well, we've been around providing engineering software development toolkits since 1996, focusing on really three major areas. That's data access, graphics, and simulation. So those are the three main pillars of our toolkits division. We've been doing that for over 750 different what we call partners in this space. So providing different software companies technology to innovate with and serve the engineering industry. And I'm calling in from our headquarters here in Bend, Oregon, but we do have offices throughout the world, including a major development office in Lyon, France, as well as development offices in Sofia, France, and in Norway, and then sales offices elsewhere. So usually you're not too far from somebody who can help you out here at TechSoft 3D. So just a little bit about our company there, very engineering focused. So over half of our staff are focused on building these engineering solutions. But what is it that we do? What is it that excites me and our team? Well, it's really fueling innovation in this area of 3D engineering. And so we're very happy to be behind the scenes providing that technology, data access, as well as graphics and simulation and analysis tools to you. And it's exciting to see what you do with that. We partner with different people that allow the building of safer cars or more fuel efficient buildings. We see our partners accelerating the design process with their end user software. And of course, no presentation these days isn't complete without talking about AI. And so this rich data that we're able to provide to you is powering the next generation of coding software and intelligent engineering solutions. So it's exciting to see what you have to do with our technology. And we have some great innovations that we're excited to talk about today as well. Before we do that and talk about our technology stack, just some news from TechSoft. So you might have seen in our newsletter over the last year, we are growing and kind of in a new way. So in 2024, we acquired two companies in technology similar to the way we acquired the CEETRON and VKI simulation and analysis software prior to that, continuing to grow, but this time it was with end user software, which is kind of new for us here at TechSoft. So in May and June of last year, we acquired two companies who actually were using our engineering toolkits, particularly in the CAD space. So that was Actify in May. Their product is the Spinfire product focused on enterprise visualization. And then Theorem in June. And again, they're focused on software for data translation that attaches to the native CAD systems, 3D PDF generation, as well as XR visualization. So kind of excited to have that technology here in-house. What does it mean for you? Specifically because it's not simulation software, but it does give us a much larger stable of experts here at TechSoft. So more talent, engineering talent that can help work on different projects. So that's really exciting. We're closer to the end user, which has always been really tough for us here at TechSoft. We did have one end user and continue to have one end user product called Tetra 4D, which is our 3D PDF generation end user software plugin for Adobe Acrobat and some standalone technology there as well. But this really is getting us closer to the industry and people who are using our software. So that's super exciting. It also allows us to kind of experience the other side of our technology. So not just creating it, but actually being customers and users of our SDKs. And so that's always very enlightening because what we perceive might be different from what's experienced. And so we hope that through this, we give you a better experience as well as users of our software development toolkits. And then lastly, it's allowed us to grow our footprint. So we have teams all over the world with an office now in Germany and elsewhere that allows us to be closer to you and service you in your time zone. So just some news, nothing too impactful to the toolkits users, but some news here at TechSoft. So how about our toolkits? Well, you might be familiar with maybe one or two of them, but we really do try to provide technology throughout the entire life cycle of product development and distribution, even into long-term archival and maintenance. And so our main pillars here, the importation of data, both CAE data as well as CAD data and data for building and construction. We have toolkits for that. Normally, you need to be able to visualize that. So a number of different graphics engines that allow you to do that, some specific to CAE, some specific to CAD data. Being able to simulate and model, of course, is critical, and then being able to export that. So again, more data access, being able to publish that to 3D PDFs, standard CAD file formats, as well as your export. So that's our stack. We're not going to talk about all of those products today. I think it's more than 15 different SDKs, but let's just focus mainly on our simulation and analysis SDKs, in particular, our CEETRON product line. So CEETRON, for those who aren't familiar with it, is our tool specific to CAE, CFD, simulation and analysis. And there's four main ones here. For data access both in and out of your application, we have CEETRON Access that reads the majority of the major CAE file formats. But then also, we provide a large selection of tools that help you along your path of creating simulation and analysis software. Particularly, CEETRON Mesh provides a powerful set of tools for meshing your models and preparing it for analysis. We have a set of tools within CEETRON Solve that help you with the solving of your FEM models. And then, of course, we're visual people. Being able to visualize both the pre-processed results and the post-processed results and everything in between, CEETRON Envision is a graphics engine specific to the CAE industry. So with very specific tools that help you navigate your data. So we're going to focus mainly on CEETRON today. However, we do want to just make mention of two other products that our users find quite helpful. Hoops Exchange is another data access toolkit, but it's specific to reading and writing CAD data, specifically reading over 30 different CAD file formats like CATIA, NX, JT, STEP, IGES, SolidWorks, can go on. The list is quite extensive, but it allows you to bring in multi-CAD into your application. Some of that data does have challenges, so it's not always good data. So we also see a lot of our users using Polygonica for data prep prior to meshing. So it's a polygonal meshing they call it a mesh modeling tool, but really it's amazingly powerful at healing meshes, making them watertight. And we do see a lot of people using that. If you're interested in either of those products, we'd be happy to talk to you, but it's not going to be the focus of today outside of talking about some integrations with the CEETRON product line. So that's just TechSoft. Briefly, we can spend all day talking about that and our different toolkits. Let's focus on our CAE tools, and I'll hand it over here to Andreas now to talk about where we've come from in the last year with some of our major features delivered. And Andreas, you can unmute, just make sure that people can hear you.
That's
We're
a
good to
good
go.
idea.
Thank you.
This is much better. I was saying thank you for the introduction and welcome to everyone. I'll be running you through the events of 2024, what features we have delivered over the past year. And then we'll have a look at 2025 with things that are still to be developed, but also some features that are already available. So let's just dive into it. I'll start our 2024 review with the multi-threaded surface meshing that was implemented in CEETRON Mesh. We had a preview release in late 2023, and the official release came in February of 2024. I wanted to come back on this feature because we have been collecting some feedback from our users, and I wanted to give you some idea of the performance gauge you could expect. We're looking at 10 speedups of 10 on 16 to 32 threads. All this is case dependent, of course, but we do have some compelling data showing that this multi-threaded approach is giving good results. Have a compelling one that goes from 1.6 million nodes to 7 million. This feature has helped the partner reduce the meshing time from about 1 hour to 3 minutes. I also wanted to give you some insight on what we're doing behind the scenes, what methodology, what algorithm we're using. It's really, I would say, a simple idea of divide and conquer. Given a surface like that green sphere on the slide, we split it up, we partition it in multiple subsurfaces. There are 2 here in the example. Then we sort of freeze the edges. We don't let them move. We don't let them be split. Nothing has to happen on those. This allows each subsurface to be completely independent, and thus we can send it to different threads to be handled in an independent way. Of course, when that's done, there are issues around these edges that we just froze. And then we tackle that by extracting the areas that have not been meshed and applying the same process. We partition again, mesh, and if there are still boundaries that have not been treated, we will do it maybe an extra time until we get the final output. So that's the way we're doing it. And using this, you can expect up to 10 times faster meshing, surface meshing. The next feature I wanted to come back on is what we call operators. This is available in CEETRON and Vision Web. It's a framework that allows you to develop custom interactions in view, so really interacting within the view to provide a better user experience. I'm going to move to the next slide. I have a few examples here. The first one is dynamic cutting plane. Given a model, this operator allows you to place a cutting plane, move it around, and really inspect the model very close and very comfortably. A second example is going to be the ability to add any selection tool. Here, for example, a box. This is useful if you're maybe selecting faces to apply boundary conditions or some nodes to specify a mesh size. It's a pretty common case of needing to define sets, and boxes are one way of doing it. You could add other methods of selection. And the final example I wanted to illustrate is the ability to actually move transformed objects around, maybe to put them in contact, completely adjusted. This could happen if you're simulating an object with some molds. I'm thinking of forging simulation applications here where I used to work. It was a pretty good thing to have to be able to move the objects around. Here you can do it within the view in a very comfortable way. And finally, the most obvious one, I used to be a customer of CEETRON in the past, and I would really nag them to be able to change the built-in navigation commands. I would have liked to be able to specify which mouse and keyboard combinations would produce a pan, rotate, or zoom. This is now completely doable with the operators. I'm going to talk a bit about CEETRON Access. The main change this year has been the introduction of a framework that allows to write readers as plugins. This really stems from two things. The first one, we have seen partners who have their own proprietary formats and who were asking us to be able to add those formats to CEETRON Access in order to interoperate with the other formats that are naturally supported with Access. So maybe reading that format and then exporting it to maybe a Bacchus or ANSYS or an Astran. That's one use of this plugin framework. The other idea behind it is to start presenting CEETRON Access for the data structure that is behind it, and seeing it more as a universal finite element data model than a catalog of readers and writers. Forgot to mention, if you do develop a plugin, it will be instantly reusable by Envision. This is one example of integration of our different toolkits. We want our tools to be able to communicate and interact with each other to bring you more development power. As a consequence of these plugins, we were also able to add a couple of readers to CEETRON Access. The first one is a format that was not supported. It's the unstructured grid VTU format of the VTK toolkit, kitware. This is currently available. There is support for parallel VTU, PVTU as well. And we will be working on the other formats that use VTU, VTM, and PVD in the coming months. The second reader that's added is sort of a duplicate. CEETRON Access already has an OpenFOAM reader, which is very extensive in its data coverage, process, setup and results. But we had this optimized OpenFOAM reader who is maybe 3 to 5 times faster. It's multi-threaded and is very cautious in its memory consumption. It's very much focused on post-processing. I'm not going to say it can completely replace the existing OpenFOAM reader, but if you're really focusing on post-processing applications, this is definitely the way to go. A word about CEETRON Solve. The main addition this year was to start providing some documentation on the accuracy of the solver. This is, sorry about that. This is interesting for you. It really gives you some confidence in what the solver is doing and can provide. But it's also interesting for some of your partners that may need such documentation to certify their own applications. I'm thinking of areas like the medical device industry or aerospace. This document is provided with the release notes. It will be extended as we move on with more benchmarks. And for the benchmarks, we have not reinvented the wheel. We're just running through the standard NAFEM benchmarks. They're sort of industry standard here, and you can relate that, and you can compare CEETRON Solve with other solvers, by the way. Now, generally speaking, we do take one release every year to upgrade and keep your favorite toolkits up to date. That could be in terms of supported language, the development environment, the API itself, keeping it lean and not overcrowded. We did this 3 times this year. Once for Solve, Access, and Mesh, which is now in its major release 2.0, 2.x. From there on, the baseline language will be C++ 17 or C17. We upgraded the Makefile build system that was there since the late 90s maybe to CMake, which is a more modern and more flexible way to define projects and build them. And we did your usual API housekeeping, removing unused functions, unused parameters and functions, and overall trying to make it more user-friendly. We're also working towards separating our different components. Solve, Access, and Mesh are delivered as one big package, as you know. We are looking at making those components independent. That's a good engineering practice. We can focus on the development and validation of each component separately. For Envision 2.0 had more or less the same goals as Solve, Access, and Mesh. bringing it up to C++17 and keeping its API lean and self-explanatory. Then at the end of the year, in preparation of the CAE Streamer project, my engineering team told me that we had to go into strict mode for the TypeScript API. This means that there is enhanced type checking in TypeScript and gives us a higher quality and more robust code. Not only us, but it will do for you as well. Finally, I wanted to have one slide about partner satisfaction and support. This is an area where we invest quite a lot, and I would like to share the good results we're seeing. We have set up a very efficient engineering process, workflow, and we're seeing the results of that. When you look at the number of partners, we've had more partners over the years, of course, well, luckily. And at the same time, we've seen the number of issues decrease, and that decrease is continuing. So we're very happy to have this, to share this. We spend more time on adding valuable features for you than on fixing bugs and other issues. I also wanted to say that in terms of resolution ratio, how many issues do we solve versus how many we receive? I have no definite figures there, but we are way above industry standard percentages. So that was it for 2024. Let's have a look at what has been done and what will be done in 2025 now. First in line, Jonathan said we would be focusing on CEETRON, but did also mention that Hoops Exchange has a big role to play in the CE workflow. It's sort of the entry point where the geometry gets into the workflow before becoming a mesh, being simulated and post-processed. There is already an integration of Hoops Exchange with CEETRON Mesh, meaning that you can use Hoops Exchange to mesh any of the CAD formats that Exchange supports. But this year, we'll be taking that a step further. Well, the Hoops Exchange team will, by providing computational tessellation. Historically, Hoops Exchange was not connected to CAE, but now, again, in an effort to integrate our toolkits much better, and so you can get the full power of them, there is this will to provide a computational tessellation. As we all know, for meshing, tessellations have to satisfy a number of conditions, and this is the object of the development, to provide watertight, manifold, and tessellations without any self-intersection. The idea is to implement this in multi-threading. There's also the idea to see how much meshing is being done here, and we do have the technology in CEETRON Mesh. We are looking at providing the ability to control to some extent the quality, the size of the elements, and also the geometric fidelity of the entire surface. In terms of CEETRON Access, looking at CEETRON Access, this is about to be released or has within the last hour. It's really cooking in the oven. We are adding a support to DPF, that's Data Processing Framework of ANSYS. The support is limited to the reading abilities. The DPF framework adds also the ability to do some pretty complex post-processing. We're not into that. We have interfaced the readers, and this means that we will be able to support and access any readers available in DPF as it is being developed. You will be getting the native ANSYS readers for these. There might be some duplicates at some time. You know, we support a few ANSYS products already, but we see this, we think that this really has added value. As you can see through ANSYS Mechanical, for example, the native reader has features that we do not support, and I'm really looking at support for distributed files here. Also, we will be adding formats. ANSYS Motion will be available as soon as the release is out. And further down the line, we will finalize the validation of the LS Dyna reader as we move on. And you can expect to have more formats as DPF is developed. Now, I mentioned every year we like to take at least one release to take care of our APIs. This year, we will be working again a bit more on Solve Access and Mesh than in Vision. The idea is to provide a full C++ API, deviating from the current C API, Try to align it with Envision. We would like to have a consistent product line for CAE. And this is a big job. I want to reassure everyone, the old API will still be available. We are thinking very thoroughly about the design of this. We want to have an extra layer wrapper, if you like, to provide the best of both worlds. So core development will still be in C, but what new users or users who wish to upgrade will be able to make use of a lean C++ API in the way of Envision. Another idea behind the lines is to start opening up CEETRON access, which is really the reference SDK for data access, CAE data access. Open it up to other use cases, other markets, I was going to say, but other workflows. That's the word. By providing it in Python, there are things that open up. For example, post-processing, could be able to automate that with Python. Something we already do a bit with Envision, but don't have as much data as Access can provide. Combining that data access with other Python tools in the ecosystem, you can really see applications that will lead to automatic reporting. If you combine that with Envision, you could even add 3D models into your report. Yeah, very new applications, very new workflows. And of course, being in Python, the idea of using all this CA data for data science or AI applications becomes very natural. Finally, again, another SDK integration feature. This will be in CEETRON Envision. There's already an existing integration, a bridge in between Exchange and Envision, meaning that if you have both products, you can easily import any of the CAD formats supported by Exchange and visualize the tessellations and some of the part data in Envision. It's not going to go through the full assembly and the PMI, all the hardcore CAD data, but you are going to get the geometries and part colors, part information to be able to do some pre-processing in Envision. We're going to improve this to make your end user workflow much easier by introducing a mapping in between the surfaces and the mesh, the objects mesh. This will allow to set boundary conditions on the surfaces and independently of any meshing operation. So really improving the workflow. Okay, those were very nice features. I'm really excited to know that Access will be providing a Python interface, that we will have this new bridge. But the real exciting thing this year, which we have been working on for some time now, is this CEETRON Envision CAE streamer. This is a new component in CEETRON Envision. The idea behind it is to really simplify and make the web transitioning a desktop application to the web, as easy, as efficient as possible. This is done after thought. We really understood that it's not only a security question, the fact that people are not transitioning as fast as you would expect. There's also a cost involved here. So CEETRON Envision CAE streamer is there to try to reduce the amount of work required to move to the web, and also to preserve all the years of work that has been done on desktop and not have to start from scratch, basically. So it's really maximizing the desktop reuse and hence, limiting the investment. So it's a streaming service. We'll be running in the background, waiting for data to come in, and application logic will be communicating with the service through either gRPC in a very raw way, or in an easier way through a C++ proxy if the application developed is in C++. We'll get back into more detail as I move on, but that's the main idea, really simplify and reduce the cost of moving to the web. I will be giving a demo in a few minutes or a few seconds. I just want to set up the context here, looking at what a typical desktop CAE application looks like. This one with an interface. You typically have a window full of widgets that allow user interaction, buttons, menus, combo boxes, whatever. And typically in the center of that window, you will have one or multiple views where the models are displayed and people and users can interact with them. The way it works is that the user clicks on a button or whatever, that user interaction is immediately accessible by the desktop application logic. There's a response to that action. Say the user asked to look at temperature. That request goes into the application logic. In this case, it will look into the file, get the data, the temperature field, and generate the visualization model, doing all the texturing of the triangles. That model will be sent back to the rendering engine, and the 3D graphics view will be updated. So if you want to take this to the web, well, there are a number of things you can preserve, but you are working in a client-server environment. The client is going to be a browser. It's going to look very much like the desktop application, except that it's in a browser, that the graphics are probably using something like WebGL, not OpenGL, and the interface is the same. There's a bunch of widgets that allow the user interaction. Clicking on that same button to see temperature, the request is sent over to the application logic, which is remote on a server. That usually is done through a REST API, and the application logic does the same thing. This is a point we're going to try and set up the tools that allow to keep all this application logic. The application logic will, bring out the visualization model. There's an extra step usually here. It will be creating what could be called a CAE display model. This is built from the mesh and the results. You're going to compute the convex hull, visible convex hull, the faces that are going to be visible. You're going to use the scalars to do the texturing. So there's an intermediate here where, you're getting the raw CA data that is necessary to generate the visualization model. This is where the CEETRON and VisStreamer comes into play. Through gRPC or a C++ proxy, you can send either of these informations to it, and the streamer will then stream that data over to the Envision renderer. There are various use cases. We're still trying to wrap our heads around what exact workflows are going to be used and possible. There's a preview version available here, and we're going to be looking for feedback quite quickly. So if anyone's interested, do reach out to me after this presentation. We'll be glad to gain more feedback. Just to come back to the possible workflows here, well, if you really want to retain exactly what is seen in the desktop application, you're probably going to want to just, let the visualization model that's generated here stay exactly the same, provide it to the streamer will send it to the renderer, and ta-da, you will get exactly the same visualization. There may be some optimizations that can be done. Imagine the use case where you want to display hundreds of thousands of vectors. It might not be in the best performance interest to do that completely here, because you're going to be streaming a lot of data. Might be more interesting to send the vectors, let CEETRON and Vision handle those, and produce the rendering artifacts here on the client side. Envision has been doing this for over 30 years, first on desktop, and then on web, and is really, really highly optimized to handle this CA data in an efficient way. So anything goes. It's really a very open world, and we're really looking forward to see what workflows come out of this. So now that I've set up the scope, I'm going to run this demo. First of all, I am going to start it up. This script is doing a number of things. It's starting the service. It's going to open one of our desktop applications, and it's going to open the client, the web application. So the desktop application is what we call CEETRON Analyzer here. We're going to be using CEETRON Analyzer's application logic to do all the computations, the data processing, and the display model generation that will be streamed over to the client side through CAE and VisStreamer. Yep, that's it. And then on the client side, we have this very simple web application. It's far from being feature complete, but at least it's serving the purpose of demonstrating the idea of the streamer. It starts with a mock-up model here just to make sure that everything's up and running. I'm going to be clicking on initialize. That request is going to go back through REST API to CEETRON Analyzer. So it's application logic. The application logic will say, oh, I have to open a file, get the elements, and transfer that over to the client. Here we're sending the raw CA data, and we're letting Envision Web do all the rendering. So let me push on that button. Okay, there's two models in the example, actually. Here's the first one, which is in this view over here. Oh yeah, we are also duplicating. We are rendering on desktop too, just for testing purposes. We want to make sure that these are in sync. So the application logic generates a display model, we render it on desktop, and then it's streamed over, and we should be getting the same thing over here. Here, well, the two models illustrate the fact that the streamer supports multiple streams. There's the other model, and really gives a very flexible way of handling different models, different views. You can also, it supports multiple clients, so you could think of collaboration workflows. It's really a very versatile tool to work with. I'm going to go back to the first model, did it again. I'm going to get rid of this. Well, actually, I'm going to get rid of Analyzer altogether. Again, this is to emulate a server. It's distant. The end user doesn't see it. I'm just going to put it on my other screen and focus on the web application. And every time I'm going to be doing something here, well, interacting, again, it's going to follow the same process. Request goes to the application logic processes the data, generates a display model, sends it back to the web, and the view is updated. So I can go to the last stage here. Someone put some custom navigation. I'm not used to it. You can go to the last stage. You can show different results. You can a cutting plane. You can change the draw style. Yeah, very basic features, but really this is to illustrate the purpose. So yeah, I said we were showing that on desktop to check. So I'm going to bring the desktop side back, and yeah, this really shows what's happening. Again, the request goes here, display model is generated, updated on desktop, streamed over to the web, and updated on the web. It's a very simple demo. I hope that this really gives you a good understanding of how things work. I hope I have been clear also on what the data the streamer can handle is, the two types of data, either sort of raw CA data or directly the visualization data that's already computed on the desktop side. Another point is that that data, since there is a gRPC interface to the streamer, that data could come from any source. We're looking at CE applications with an interface, but if you want to do it with Python, so be it. If you wanted to develop something in C#, whatever the input is, you can run through gRPC, which is a standard protocol. That sort of ends my demonstration. I am going to hand things back to Jonathan.
I think you may have just one more slide, Andreas, talking about
The roadmap. I
your
completely forgot about
yeah.
Yeah. Okay. Here's the roadmap, just to have on one slide a summary of the 2025 year. As I mentioned, a version is being produced as we speak. That will contain the ANSYS DPF interface with the new ANSYS motion format, and also support for distributed at RST files. We're also updating Abacus to Abacus 2025, the interface, input and output. And Nastran, we are validating. Nastran is updated continuously. Next version will also validate our RST reader, and confirm that 2025 is supported. And then we will start on the solve access and mesh side, start really working on the C++ API. That's not a minor task, but we will be working on it during the spring and summer, hoping to bring it out sometime early September, and immediately hop on to wrapping that and to obtain a Python interface. On the Envision side, I hope I convinced you that our big project this year is really the CAE streamer. Again, there is a preview available as of now, but the first official release will be on April 4th. We hope we will have many new users that will be able to provide feedback. That's probably why we are reserving some resources. We are expecting to get feedback and have maybe 1 or 2 versions more as we move along. And the CAD to mesh mappings will be something that will come out probably early September, as far as I can tell right now. I think that wraps it up, unless I
Yeah.
forgot another one. So now it's up to
No,
you, Jonathan.
no, that's great. Thanks so much, Andreas. And that VisStreamer is exciting technology. So we're looking forward to seeing more of that in the very near future. A few other things to look forward to, just be aware of coming this year. We do have a naming rebrand for some of our toolkits. So just wanted to make you aware of that. It's not significant. It's happening later this year, but the CEETRON product name is going to be consolidated with Hoops. So Hoops will become our major SDK product family. Still, all of the products that you use and love are going to be available. So no real change there, just the name. So Hoops Access is CEETRON Access will become Hoops Access. CEETRON Envision will become Hoops Envision for CAE graphics. And then for simulation, CEETRON Mesh and Solve will become Hoops Mesh and Solve. So we just wanted to let you be aware of that as we're trying to just simplify our product portfolio. Hoops is already a very well-established brand in the industry. In fact, people know us more as the Hoops guys than TechSoft 3D, it seems. So we're really embracing that. But no huge change, just naming this rebrand. And we are going to continue from an engineering standpoint, really trying to bring these toolkits together as they work as a family for data access, graphics, and simulation. So do look forward to that. It's happening second half of this year. So just wanted to make you aware of that. And I think that's it for renaming. But then we also have a number of events that we would love to connect with you and make you aware of. So for our existing right now, our Hoops product line, that is data access, graphics, and publishing for particularly CAD data, we're doing this same webinar, but for our CAD users in 2 weeks. So that is virtual, same thing, what we've delivered, where we're going with that technology. So if that interests you, we'd love to have you come back and talk with our product managers there. We'd also love to connect with you in person, and there's a lot of opportunity to do that in the very near future. So we will be both at Wind Europe and NAFEMS presenting papers at both of those. So at Wind Europe, we'll be talking about the integration of some of our graphics and open source solvers. And then at NAFEMS, what Andreas was showing you there with the CAE Streamer, officially we'll be releasing it and showcasing it. And we do have a poster at NAFEMS. We'd love to connect with you there. And then lastly, something to look forward to is we will have our Hoops Summit, which includes all of our brands, all of our SDKs. It's going to be really a 2-day event in Lyon, France, near our development office and, in fact, at our development office. So day one is talking about where the industry is, building engineering solutions using our toolkits, both our simulation and analysis toolkits that you've seen today, as well as some of our CAD and building and construction toolkits. We're inviting our partners to come and showcase how they're using our tools within their applications. So you get to see our SDKs in action. In fact, we do have a few extra slots for that Hoop Summit. If you are interested, you're already a partner of TechSoft 3D and you might want to present, we do have a few extra slots there. Please reach out to Andreas and myself if that interests you. We'd love to have you there. And the second day, in fact, we will be relocating to our office for a developer day. And that's where you'll get to meet with our staff and really roll up your sleeves and look at code, work on your problems, prototype, walk through challenges. So we're opening up our office to entertain engineers. We'll have a barbecue, but more importantly, you'll meet with our consultants. You can meet with our engineering team. You can meet with our product team to talk about the future and your needs. So really, it's a 2-day event. So super excited to have that happening in Lyon in June. It should be a nice time of year to visit. If any of those interest you, right here, you have a QR code to go to our events page on our website, and we'd love to meet you in person. And I think that's it. We have some time for Q&A. So let's actually, before we do that, just make sure we throw up contact information for both Andreas and then also our dedicated CAE Partner Development Manager, Hunter, new to our team. If you have sales questions, want to look at one of these toolkits, reach out to Hunter. He's your guy. Super excited to have him on board with us. So there's your contact info, and then we got a bunch of questions. I'll hand it over to Charisse, and you can walk us through that.
Sure. Thank you so much, Jonathan and Andres. Like you said, we had some great questions come in during the presentation. So let's go ahead and share some of them. First one we've got here, does your visualizing tool use web GPU?
Yes, absolutely. No, what GPU? Sorry, I understood WebGL. No, web GPU is something we are investigating. I did not dare put it on the roadmap. It's technology that's being looked at closer by the Hoops communicator team, which is the CAD visualization toolkit. Our team, the CEETRON and Vision team, is part of that project, but really on an observer basis at this point in time. It could well be that as we move along, we invest some resources if we see there's an opportunity to leverage what the communicator team is doing.
Thank you, Andres. Here's another one. Hello, team. Thanks for this session. Does CEETRON Mesh support hexahedral mesh elements? And if not, do you plan to support it? And additionally, will this recording be available and the slides?
Okay, so no, we do not support hex meshing. We support in volume, we support full TET meshing, and we also support TET meshing with transition to quad surfaces with pyramids, basically hybrid. There is no plan today to support hex meshing. It's a very heavy technology we are not looking at for the moment. But thank you for raising it. If we get enough requests for that, we will look at that. And yes, I think the recording will be available and the slides will be shared.
Yeah, so give us a couple days to get the recording up, and we'll send that out in an email. It'll also be on our YouTube channel.
Absolutely. Another one we've got here. Do you have an example of using Streamer for a third-party application? You showed peer review in your initial example slide. Are you able to remote something like that?
Well, that was only a slide, and no, currently, again, it's really fresh out of the oven. It's not even released, but you are touching a sensitive point there. I think we are going to look at producing a demo that piggybacks on peer review at some point, taking peer review visualization and streaming it over to the web. Again, if you have an application that might be a good candidate here, we are really eager to hear from you and do reach out to get your hands on the technology.
Thank you very much. We have a few more here. Can I use the Envision CAE streamer with a desktop application not built on Envision Desktop?
Yes, that's sort of, that was sort of implied by saying we could build it with peer review. Maybe I wasn't too clear in the presentation, but any source of CA data is good. If it comes from an Envision Desktop application, it will probably make things a bit easier if you want to send the display model data, but everything is possible. It's a very versatile and open streamer there. So peer review is a good example. And again, we really look forward to looking at how much effort is required to put that demo up.
Yeah, and Andres, I'd just like to add that we are already working with some pilot partners starting to use the VisStreamer in their workflow to bring their sort of legacy desktop application to the web. And several of those partners, they are not using Envision Desktop as their rendering engine. So it's sort of already in the works, but we don't have anything ready per se. What we do ship with the preview that we will ship on April 4th is some small demo application that shows how to use both the C++, it's sort of like a desktop engine, but also with sample applications for Python, for Node, and for C#.
Thank you, Frederick.
Good point.
We got another one that just came in. What is the difference between CEETRON Mesh and the CAD to Mesh mapping that's going to be released later in September of this year?
CEETRON Mesh is a meshing toolkit. It has various meshing tools, the main ones being a 2D surface mesher, which can then be fed to a 3D mesh generator. The CAD to mesh mapping does not involve CEETRON Mesh. It's really a bridge, an extension of a bridge between Hoops Exchange and Envision. It will just allow to know what faces of the mesh belong to a given surface. and hence provide the necessary mapping to allow users to select the surface for any use, typically setting a boundary condition.
Right. Well, I think here's a good one to end on. Last one. What's the difference between TechSoft 3D's SDKs and open source SDKs?
Well, it's the difference in between any proprietary technology and open source one. There are probably valid reasons to choose either or. We tend to think that support is probably better ensured, but that's one thing. Yeah, I couldn't really comment beyond that. That, yeah, if you pay, you get other service, I would say.
Sounds good. Looks like we've covered all the questions for now. Thank you all again for joining us on this webinar. We value your time and appreciate your presence. If you have additional questions, like Jonathan said, please don't hesitate to contact us. For technical and product questions, you can direct those to Andres, whose email was on the previous screen. And any sales-related questions, you can direct to Hunter Guerin. That concludes today's presentation. We hope you found it helpful and informative. As we mentioned at the beginning, your opinion matters to us, so please take a moment to complete a quick feedback survey that will pop up on your screen. Thank you and have a great day, everyone.
Bye.
Bye-bye, guys. Thank you.